Hey guys, welcome to the next video in our series. We're talking today about adding and subtracting algebraic fractions. We did multiplying and dividing in the previous one. Now we are looking at the last two operations. Now I'm just bringing your attention to a common question you would have gotten in year 7, nothing out of the ordinary. We have 2/3 plus 4/5. How are we going to try to add these? Now, just a refresher for how you would do this, I'm hoping a lot of you remember, these two fractions right now are speaking different languages to us. They're from one another. They are trying to communicate different portions, and we can't really understand those unless we look at each of them in terms of the same portion space. So we need essentially the same denominator for both. So when approaching questions like this, I'm going to go through this a bit quicker because I'm sure a lot of you are already across this. We need to find the lowest common denominator. So the smallest denominator that we can to make these two fractions, to make equivalent fractions with the same denominator. And that way we can add a lot easier. So for your lowest common denominator, we need the smallest number that 3 and 5 go into. That's 15. And we want to then make both 2/3 and 4/5 into an equivalent fraction with 15 as the denominator. So to get 3 to 15, we want to multiply by 5. And because it's an equivalent fraction, what we do to the bottom, we do to the top. So multiplying both of those by 5, we get 10 over 15 plus, and here we are multiplying, we want to get 4 over 5 to an equivalent fraction with 15 as the denominator. So we're going to times 5 by 3, and then we're going to do the same to the top. So 4 by 3 gives us 12, 5 by 3 gives us 15 as we'd expect. And now that the denominators are the same, we can just add the numerators as a numerator over the same denominator. So that gives us 22 over 15. Now a lot of students get this okay, but then the second we add algebra to this, we add letters to this, they freak out and it gets a lot harder. But it doesn't have to, because what we do with algebraic fractions is the same we do with regular fractions. So what if instead of making this 2/3 plus 4/5, what if we made this 2x over 3 plus 4x over 5? What would change here? Well, I know that both of these numerators are multiplying by x, so that just means another number's being made. But that doesn't really affect anything with our actual working through of the question and adding these together, because we still want to find the lowest common denominator, which is still 15, and I just want to make these into equivalent fractions with 15 as the denominator. So both of these numerator and denominator on the left hand side, they're once again going to multiply by 5. So 2x multiplied by 5 gives us 10x. 3 multiplied by 5 gives me 15. That's where we wanted to be, because we want a common denominator of 15. Now on the right hand side, the denominator is going to be 15. How do we get from 5 to 15? We multiply by 3. So we are going to do the same to the top as we did to the bottom, because we want equivalent fractions. So that gives us 12x over 15. And now all that's left to do is just add the numerators in the same way. And we wind up with 22x over 15. So the approach never changes. we still go through the same process. We want the lowest common denominator. We want to build equivalent fractions which will allow us to add or subtract these fractions. Now, I'm going to break this video up into a few sets of different questions. These first questions, we are going to be adding and subtracting with numerical denominators. So all the algebraic terms are just going to be on the top. So for this first example, I'm going to have x over 4 minus 2x over 5. Once again, we approach this in the same way. We find the lowest common denominator, make equivalent fractions, perform the addition or subtraction with the numerators. So the lowest common denominator here is going to be 20. That's the lowest number that both 4 and 5 go into. So I want to make both these fractions into equivalent fractions with a denominator of 20. So what number would 4 have had to get multiplied by to get me to 20? Well, that would be 5. So this gets multiplied by 5, and the same thing happens to the numerator. For 5 to get to 20, it would have had to get multiplied by 4, so I'm going to do the same at the top as well. So I have my denominator of 20. Now all I need to do is compute the numerators. So x times 5 gives me, x times 5 gives me 5x. 2x times 4 gives me 8x. And now that I have these as equivalent fractions, I just need to perform this subtraction with the numerators. So in essence, here I have 5x minus 8x all over 20. And I can see here I have like terms, so I can actually subtract one from the other. Taking away 8x from 5 gives me negative 3x over 20. That is all we have to do. It is the same way we've been working with fractions up until now. Okay, let's try a slightly trickier example. Here we are going to do x plus 3 over 2 plus x minus 2 over 5. Okay, so here I want to once again do the same thing that I've been doing so far. I want to find first the lowest common denominator. What's the smallest number that 2 and 5 go into? That's 10. And I'm going to make, once again, equivalent fractions. So I have 10, I'm adding here to something over 10. Now, what did 2 get multiplied by to give us 10 in the denominator? It got multiplied by 5. So this entire top expression is going to get multiplied by 5. Now this 5 got multiplied by 2, so this entire top will get multiplied by 2. Now, the reason I've said this entire numerator means that we need to treat x plus 3 as its own number. So what that's going to mean is that when we do the multiplication, 5 times x plus 3, I am multiplying by this entire algebraic expression. And the same way here, I'm doing 2 times x minus 2. Okay, so what does this remind us of? Well, we are going back here to the very start of this series, because this now becomes an exercise in expansion. Well, it's important to note that now that we're adding with the same denominator, I can write this as a fraction over the same denominator. This is all over 10. And now, to get this to the simplest form, now we want to expand. So we're using expansion and factorization as we need it, at what's going to be most beneficial to us in terms of simplifying something. Simplifying its fraction after we've done the addition or subtraction to its most simplest form. So here we're going to expand. So this 5 is going to get multiplied by x and 3. This 2 is going to get multiplied by x and negative 2. So we wind up with, on the top, 5x plus 15. 5 times x gives me 5x. 5 times 3 gives me 15. And here we have positive 2x. 2 times x gives me 2x. And here we have positive 2 multiplying by negative 2. That gives me negative 4. And this is all over the denominator of 10. And you can see here we have whole numbers and we have algebraic terms. We have these like terms. So the final thing to do to simplify this is to add our like terms. 5x plus 2x gives me 7x. 15 minus 4 gives me positive 11 over the denominator of 10. Now, that's how we can add and subtract with numerical denominators. Let's see how this changes for algebraic denominators. Hint, hint, it actually doesn't that much. As long as we still follow the same types of procedures that we've been doing up until now, no matter how scary this gets, we already know how to do this stuff with fractions. We learned it a couple of years ago. So we just need to apply this to our fractions, to our algebraic fractions, I should say. Okay, now in this case, we have x and 2x. We don't have numerical denominators anymore. We have algebraic ones. How can we do this? Well, we can still find, even though we don't know what x is, we can still find the lowest common denominator. So, the lowest number that both of these can actually go into is going to be 2x, because I can get this x over to 2x and this can just remain the same as it is. This is kind of similar to, if you're looking at this and going, what's going on? This is similar to if you did, for example, 1/2 plus 3/4. The lowest number the lowest common denominator here is going to be 4. Because we already have 4, but we can get this 2 up to 4 as well, and then do the addition. So even with algebra, we can get this to the same lowest common denominator if one of those values is already that, in the same way that 4 was here. So now, this actually makes our life easier, because all we need to do is get this x up to 2x. Now what can we do there? Well, all we have to do is multiply that x by 2, because 2 lots of x gives me 2x. And I'm going to do the same to the numerator here, because we want equivalent fractions here. So I get 4 over 2x minus 5 over 2x. Now I can write these over the same denominator. So 4 minus 5 over 2x. And I get left with just negative 1 over 2x. That is my final simplified answer. So even though now we have these scary algebraic letters, we can still work through it in the same way. Let's look at one more example and we'll wrap up. So we have here 2 over x plus 3 over x squared. Okay, now we don't even have any semblance of a number here. Here we had the 2, but now we have everything in terms of x. What's the lowest common denominator? Well, we don't know what x is. That's for sure. We have no idea how to work through this at all. We know that I have an x, I don't know what it is, but I have an x squared here. But let's think about what this x squared is telling us. This is just telling us that this denominator is x times x. So what can we do to find the lowest common denominator? Well, think about it. Can we get this over to this at all? Well, we actually could. This is very similar to if we had, for example, I don't know, 2 over 3 plus 4 over 3 squared. This 3 squared is just 3 times 3, or 9. So we can get that to this 9, or this 3 squared, by just multiplying the 3 by itself, and we get an equivalent fraction. The same thing can happen here. So our lowest common denominator is actually just going to be x squared. Because I can very easily make this x, even though I don't know what it is, I can get it to x squared. How do I do that? By multiplying it by itself. That is what a square number is. And what I do to the bottom, I do to the top, because I want equivalent fractions here. What I get left with, 2x here over x squared plus 3 over x squared. And all there is left to do now is just add these over the same denominator. So I get 2x plus 3 over x squared. Can I simplify this anymore? No, because I have one algebraic term and one whole number. So this is the final place we can go. Now, hopefully by now I've convinced you that even as these get harder, we already know how to do this from our work in year 7 fractions. So we're still applying the very same ideas. That is to first find the lowest common denominator. We want to make equivalent fractions with the lowest common denominator, that lowest number, as the denominator of both fractions. And 3, all we need to do then is add or subtract the numerators with the lowest common denominator at the bottom. This should look familiar because it hasn't changed at all from when we did fractions in year 7. The only difference here is we're dealing with algebra, but we already know how to operate with algebra, and we know how to expand, we know how to add like terms. So not too much is changing. But thank you so much for joining me in this video, guys. I'll catch you next time.